And then we also assume that we are familiar with arrays, right? And then functions too. We assume that we are all familiar with. Okay, so we are going to continue from pointers. So we take a look at pointers, then macros, then header files. Okay, I'm let me. Okay, so we start. So know that every variable that we declare in a program is kept in a certain memory location. Okay, so there is a reserved memory for it. Um, Memory space is reserved for every variable to store data. Yeah. So what pointers do is that it holds the addresses of those other variables. Okay. Okay, talk please. Someone said she has a question, please. Okay. So that's what pointers do. They store the address of other variables in memory. Okay. So this is what we are going to do. There are types of pointers. Yes. I would like to explain some basic theories, then we, we practice it in code blocks, right? Okay, so the first type, sorry. Okay, so the first type of pointers is going to be void pointers. Void pointers. So this pointer, this is what they do. Um, they are not associated with any data type, right? So they can point to any data type. So when you declare a pointer as a void, um, what you do is that we can it can hold the address of any data type. So basically, what you know is that um, before a pointer, you declare a pointer, you must keep the data type of the pointer. That's the data type of the address is going to hold, right? So if you are going to, we are declaring a pointer to hold integer variable, then we will say int, say then star, I'll say integer, right? Equals then the address of, sorry, I'm using, I'm writing dollar instead of ampersand. The address of the variable, say, right? So what we do is that this pointer is going to hold the address of var, right? Okay, so this is the formality of initializing pointers, right? Or defining pointers. So the data type should be stated, and then the address, the value too should be assigned to it. So if you look at this, it is an integer pointer which is holding the address of the variable. And by the rules, this variable must be of integer data type, right? Good. So when the pointer is a void pointer, what it does
Yeah,
so what it does is this. It can point to any data type at all, right? It can point to any data type at all. And this is where word pointers are used. They are used by some built-in functions, which we will talk about later, which are used to allocate memory uh, at runtime. Right? When I say runtime, I mean after we have compiled and then the program is being executing, we allocate that. So that's dynamic allocation. We'll talk about those built-in functions later. And also, yeah, so that's the uses of void pointers. So those built-in data types, sorry, built-in functions which are used to allocate memory is they uses void pointers. Okay, so the next type of pointer is called and the second one is called null pointer. So null pointer we initialize it right to null. It's a pointer that's initialized to null. So a null pointer will be like say ETR is equal to then say null. And then if you are quite familiar with programming, you will get to know that now it's just like it means nothing, right? So this is how it gets its name null pointer. It points to nothing. We can reassign it to a new address. Yes. All right, please. The void pointers. Okay, I mean, we will use it when we get to dynamic memory allocation. So, in case we are able to get there, I'll talk about the use of void pointers, but let me highlight on it. This is what it does. Um, it's it can point. It's a generalized pointer. It can point to any data type at all. So, and it is being used by some built-in functions which are used to allocate memory space during runtime. That's dynamic memory allocation. So we talk about them when we get there. So those functions, those built-in functions are malloc, calloc, and realloc, and free. Right. So when we get there, I'll talk about it. Are you cool, please? Are you okay, please? Okay, so we just finished talking about null pointers. The next type of pointer is called dangling pointer. Dangling pointers are like they're just there and they don't point to they, they don't point to any memory allocation. Like it has been initialized, but uh, we've not assigned it to a particular memory location. So this is the difference between the dangling pointer and the null pointer. So the null pointer is there and we initialize it to null. So actually, it is not technically, it's not pointing to any location. But the dangling pointer is there. We've not initialized it, right? Or we sometimes you can initialize it and then later flip it. When we get there, we'll also talk about when we get to the built-in function. I was talking about the dynamic memory management functions. When we get there, I'll talk about it. So this dangling pointer can be there and it can be pointing to any memory location at all, even though we've not assigned it to a memory location, right? So it's just there. I hope you get this, right? All right, so these are the types of pointers I think I have got to know so far. Uh, so we are going to put blocks to uh, demonstrate some pointers over it. All right, so there's my code blocks here. I have a file called main.c. So we're going to do this. So I'm going to say int now equals to say 10, right? And then I'm going to assign the location, the memory location of this num variable to a pointer. So I'll say, and since num is an integer, we have to make the pointer also an integer. So we say int star, right? Here is equal to get address of what? Address of num. Good. So now PTR is pointing to the address of what num. Okay. So let's see something. I'm going to print the address of num as an integer, right? So I'll say print g value of the format specifier for integer is percentage g, and I'm going to say integer.
Percentage P.
Okay. Okay, I think there's a mistake here. Wait, I'm printing a pointer, so I should make it specific. Yeah. Okay, so let's say this. Okay, we'll yeah, run it. So since the heading as your as a text is value, right? It's a decimal. So it means that this the integer variable, which is now is located at memory location what 0060 FE, right? So that's okay. So we can also use this. I'm gonna see. Okay, so we can also use this to um, print or access what the num variable is holding, right? So that's what we call the key reference, right? So over here, I'll say star, and I'm going to do this as well. Integer, sorry, percentage e. So now let's save this and run, and I'm going to get 10 because num is holding word 10. Okay. So did here is called dereferencing, right? So I did dereferencing over here. So this is what pointer can do. We can use this pointer to change what noun is doing. Whatever we do to the pointer, like what we have access to the address of the variable it is pointing to. So whatever we do over there affects the value, right? So I will say, for instance, I will say the dereference of ETL is equal to 50. Now when I print it, I must get on the console. So you see, 50. We have changed the word. We have changed the value of what now in voice with the pointer. Right. Okay. So that's a brief introduction to pointers. So let's see what we can do with pointers again. If you remember something in Java, when we are passing argument to a function, we can do it in two ways, by either passing it by value or passing it by reference, right? So you see, so let me declare a pointer. Let me declare a function here. Actually, I'm going to define it as well. So this function should be void, right? I'm just going to make it void, not return anything. And I'm going to say so. So this function is going to take in an integer variable and say, yeah. And what I'm going to do with this is that I'm going to, sorry, what I'm going to do is that I'm going to print the square of whatever variable we do was we pass in and we add it, right? So and I'm going to say what bar 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 bar. Yeah, I'm just saying bar actually. Okay, so this is what this pointer is. Sorry, this um, function is doing. So over here, I'm going to let me comment out this here. Comment out this ring assignment. So I'm going to call this function and pass in count, right? And then you see what it does. So this is where. I'm going to say now. Now when I run this, I must see the square of the value of what? Sorry, yeah, the square of, yeah, the value of, okay, so let me save it. So that's what, 100, because now it's holding the value 10, right? Okay, so let's do something over here. Let me do this out, and then do this again, right? I'm expecting now not to hold end again because I'm using this pointer to change the value in now, right? So let's run this again and see. we should get 15 squared. I guess. Yes, so 15 squared, that's what 255. Am I right?
Yeah, help me out.
Okay. So with pointers, we have been able to manipulate what the variable is holding, the values of the variable. We've been able to manipulate it without explicitly naming the variable, right? Okay. So we can also do this over here. This um, square function takes this variable, and here we are passing this variable as what by value, right? We are not passing it by reference. So whatever we do here, we will. It's like we are sending a copy of this variable to this uh, square function. So it's just a copy that we send it, and then after we are done with it, we neglect whatever is here, whatever is in this function. But the variable over here still holds its value, right? So I'm going to comment this out again. And over here, I'm going to reassign bar, right? And print it. So over here, since I've commented this out, now our non-variable is holding what 10, right? And the pointer is holding actually the aggressors down, right? Okay, so we pass now as an argument to the square function. And over here, I'm going to change it, right? I'm going to change bar. And so bar, I'm going to reassign bar is equal to 12, right? I'm going to print uh, the square of bar, right? So over here, after this, I'm also going to print num over here to show that this num variable has not been changed, right? So print this, and say decimal. I'm going to say num. Okay, so let's save it and then go and run. Oh, sorry. It has count them together because I did not state I did not break the line, right? So when you break the line over here, that's backslash n. Yeah, I can optionally do this check. Let me break the line here. So if you look at this, our num here is 10, right? And we pass the 10 here, and we change the value of bar, right? So this bar will take the value that's holding, that's held by the num function over here. So when it passes, this bar will be equal to 10, and then we reassign it, right? So if we reassign it, then we might think that we have changed the value of what num because we passed num here, but because we passed by value, it's just a copy, right? So we'll get the square of 4, which is 144, and then over here we want to print num again, and num is still 10. It is not changed, right? Okay. Okay, so let's do this. Let's use this. Let's pass this variable by what? By value. sorry, by a reference. So I'm going to find the parameter to be a pointer, an integer pointer. So this bar now is what? It's a pointer. Okay. So when we do this, we are going to say that the reference we dereference bar over here and change what num to what 12, right? Then we are going to print x squared, right? So I'm going to say print bar. I'm going to do references. Okay, let me put them in parameters so that you don't cause bar size right? So we work the amount, and then over here, I'm going to say PTR. We can either say the address of num. We can do this. And when we do this, we are passing the address, but this address is being held by pointer PTR. So we can also just pass the pointer here as PTR. And this should be the same. Okay, so I'm going to do the two versions, and then we see that we'll have the same result. And over here, the value of num will change to what we do over here, right? Over here, we not in the main function, we do not change the value of num. Num is still there, but in this function, we're going to pass the reference of this num to this function. And then we're going to change it to what? 12. And then after that, we expect our num to go to 12. Okay, so I'll say that. Let me first pass the address. Right. Now let's do this. Do them run. Okay, so we have what? 144, sorry. 144, that's what 12 square. And over here, this second 12 that we see over here is a result, it's as a result of this printed function. And it is giving us what? 12. But in this main function, because we assign um, the num variable, it's still 10. But when we pass it by reference, we were able to do it, change it to 12, right? So now it becomes 12. So we can also do this let me close this. We can also do this by sending in the pointer. So it's here. And it does the same thing as the previous system. Let me do that manually. And you get the same results. Right. So that's a brief introduction to pointers away. Okay, there's another way, there's another scenario for pointers. When it comes to arrays, the name of the array holds the address to the first element of the array, right? So, for example, let me do this here. Let me look at integer array. I will say the size should be 5, right? And I'm going to initialize the say one, two, three. Right, right. Okay, so this is the size of the array. That's fine. Okay, so I'm going to pass this array to this function, right? And I'm going to comment this out. I won't change it so that we get to know that it should print the address of what? Sorry, the square of 1 because 1 is the first element, right? Okay, so over here, let me comment this one out. So I'm going to say some square. Square, and I'm going to pass AR out, right? So over here, we should get 1 printed because 1 times 1 is 1, right? Okay. Yeah, I got, oh, sorry, I did not put semicolon here. And we get 1, right? So it's printing 1 times 1 times 1. Okay. Okay, wait, let me do some experiment here. See if this will work. Let me see, let's again, but right, so we are passing through, right? Let me check if this will work. I've not tested it before. Okay, this is another way. Let's see. So this one more way, right? So this it means that this a pointer, right? This taking a pointer yeah, as a parameter. Yeah. This has a pointer parameter, but here we are passing a what? A value, right? So with arrays, it's only the name. The name points towards the address of the first element. So if you want to pass the address of this, then we should put the address of data here. So when we do this, we should get the address of the second element. That's what index 2. So this index 0, 1, 2. So we should get 3 squared. That's 9. Right? Wait, let me show this. Okay, so I'm going to run it again. See. So that's 9 even. So we have passed the address of what? Array. Yes, the second elements, right? Our third elements, yeah, because in tests, so this 2 here is pointing to the third element. So we pass the address of 3 here to this variable and we square it over here, right? Okay, so that's a little something more about pointers. Okay, so now we will move to this is a crash course, so we won't do much about it. So we will move to the next topic, which is sorry, which is macros. Yeah. So what are macros? When you say macros, what's macro? What's a macro? Let me comment this. don't know. We, when we're doing assembly language, last year, we were talking about macros. I don't know if we still remember or something. Yeah. But this is the whole thing. With macro, you can hold a code snippet like or a value, a constant value a as a variable, right? Let me say that. Yes, you can write some expression to represent another, right? So anytime you call that expression, it becomes a what? It get represented as such, right? So for instance, before we go to macros, we have to understand directive, right? So these directives are special commands that we give to the compiler. Okay. So directive. So these directives are special commands that we give to the compiler. So at the beginning of the code, before we write any value statement, we have to put in all our directives there. So if you look at this, we have a directive here called hash include, right? And there is a header over here, stdio.h. This hash include is the what? It's a directive. So this tells the compiler that we want to add something to this file, right? But what you want to write add to it, so this stdio.h and then stdlib, that's the standard library.h. These header files are just, they are nothing but they are different files that we are including in here. So what this, okay, we'll talk about these things when we get to the dealing header files. So this is called a macro. It's a special directive. This is a directive. It's a special command that's given to the compiler. We call it preprocessor, right? Preprocessors, right? So, okay. So the first one we're going to talk about is hash define. So if you want to write a directive, the first thing should be hash. So you say hash define. So this hash define is used to define macros, right? So it's a preprocessor directive. So this hash define will tell the compiler that we want to define something that it doesn't know. Let me explain myself, right? So the compiler knows all the built-in functions expressed, but if you want it to do something special, we have to tell it that this is what we want it to do. So we are defining what we want it to do with it. So this preprocessor has defined. That's what it does. It defines a macro, right? The second preprocessor directive is, I will talk about hash define, right? Sorry, hash include, right? The second one is, the next one we talk about is on the hash on the. So if you look at this is hash define. This is defining a word, a macro, and then this is doing what undefining it. So after we define it, we have what this one will just undefine it, right? And then the next one is hash if ended ended. So This tool is a preprocessor that is like a conditional preprocessor directive. So we are saying that if something is not defined, that's the meaning if and if this is true, then we want to do something, right? And when we are done with whatever you do, so this you take examples when um, we take time to talk about each of them later. So when we are done with this, we put in whatever we want to uh, we put in whatever we want to um, define in here, right? And then at the end of this, we end it. So we say as what um, and okay. So that's another preprocessor over here too. Okay, the next one is just hash if. This is also a conditional, right? So it's like we are defining an if condition, a condition as a preprocessor directive, right? And then we also have um, there's one built-in that we talk about called hash pragma. This is a special directive that we use it to um, tell the compiler how to handle memory. Right? Actually, there's another different directive name that we add. Right? So this pragma is a special uh, preprocessor that tells the compiler how to handle memory. We'll talk about it when we get to structures. Right? Please, if you have a question, just interrupt me and tell me that you have a question. Or if you have a contribution to. Pardon? Yeah. You said the hashtag if. I'm gonna let me open it. Hashtag if. Uh-huh. Yeah. This one. This one. This one. Are we talking about what I've circled? That's hash if, right? This one, right? It's just hashtag if, right? It's used to check, to test if. Pardon? I didn't get what you were saying. Okay. Hashtag if this. No, 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 we don't have. I've not come across something like that. Right. Okay. Okay, so these are the preprocessor directives, right? So let's see what macros are. So macro. So these are special, like we use it to hold code snippets. When I say code snippet, I mean like a code sample, right? So we will say hash define, and I will say For instance, we want to pull uh, um, a constant, right? So let's say pi, right? So you say pi, and in most conventions, we use um, capital letters to um, to denote what macros, right? So we do this hash define pi. We don't create equal to sign over here, and then we just write 3.14 whatever over there. So in the program, wherever we mention pi, it will get replaced by what value is satisfied over here. Right. We can put a statement here as well. So we can say hash the define um, I'll say message and here I'm going to say put this string there as hello hello Dimas. Right. So when we do this in the program, whenever we mention this message, it will get replaced by what? Hello Dimas. Right. So this is what we call macros. We are using uh, a particular um, no, this is a variable, a particular way, right, to represent a code statement or a code block or something, right? So we can use this to also hold function. Macros can take in parameters and they like functions. So for instance, I can say that hash um, square root. Sorry, we can think like this. So we can say hash define right? And we put in here, right? And take this thing here and input here. So say X, right? And then over here, we are going to replace this as the word SQRT. That's a mass inbuilt function with for mass, right? So SQRT of what? X. So whenever we mention this and put in a value here, it's going to get replaced by the square root of what value we place here, right? Okay. So another way we can use macros is this. Let's say you get bored, right? And you in your this thing, um, in your program there is let's say a particular strings that you want to use most of them. And let's say I'm just assuming that you see in C we don't have a data type for strange, yeah, right? As a data type like as we have in other programming languages, right? So you can represent a strange. You see, string is a like an array of characters. So like the string is like this. Sorry, the string is like this. Let's say before you can pull the string, you say the car. Uh, let me see the length of it, right? Into 10, and we initialize it to whatever you want to load here, right? Good. So you can also use a macro to hold this. So we can say hash define string, and then we say and whatever length you want here, let's say 20, right? So, so oh, sorry, actually, I have to give this a name. I didn't name it. It's a nameless variable. So I'll say in car name, and then what's 20, right? Let me say 20. So this string, what in the program, whatever you mention string here, it will define this word uh, character array, right? Which is strings, right? Okay. So let's get into code blocks and then do some practice about it. Okay, so here I'm going to comment this. Okay, so over here, I'm going to define a hash define a age. And I'm going to give you this value as 14, right? So in the program, whatever you mention age, will get replaced by what? 14. This one we are defining macros, we don't put a semicolon or after we don't terminate it, right? Okay, so over here I'm going to say friends. Let me use this friend. Okay. Oh, sorry. Forgot my have commented everything. I'm going to say change this more. I'm going to say age. Yeah. So over here, our age is what? 14. So when I do this, I'm expecting 14 to be printed on the console, right? Say I'm going to build them and actually 14 document. So this age is holding 14. So whatever we mention age, we will actually do it. Represent it will get replaced by 14. So it's just telling the compiler that, hey, compiler, if you see age somewhere, I need 14. Okay. So over here, I'm going to take this, initialize this preprocessor to a variable. So my age. Let me take a comment this. My age here is equal to age. So if you look at this, what we are saying is that and my age equals 40 because this preprocessor macro is what? It's holding 40. So I'll just say my age here. So over here, I'm going to build and run it here and 14 is here. Okay. So assuming that we use my age like 100 times in our code, and then there's a mistake. Let's say the age we saw was wrong. The age is 16 instead of 14. But because we have used age like 100 times in the code, it will be very tedious and in fact you feel lazy to go through the code and change age from 14 to 16, one after the other in each line, right? So since we stored 14 as a macro over here, you just come here once and say 16. And whatever age is written in the code will get replaced by what 16. So here it can save our time of correcting the code, right? Okay. So over here, I'm going to run and build this, and it's going to tell me what 16. Yes. Okay. So that's matches for us. So, okay, let me do one example by using it to code snippet, right? Hash my read, sorry, read, read it. I'm going to explore this string here. Include it. Right. So I'm going to say that greetings. So this greetings follows what good evening. Right. This is it is a string, right? And we're holding it as a word, as a macro. So when we save and run it, so we get 16 good evening. Yes, I guess we understand why this is so. Because here we not move to a new line, right? So it will get combined on the same line. Right. So when we run it again and we get so we have 16 million words in evening. We spend about some time already. So let me quickly go through the next topic of header files. Right. So what is header files? What's the header file? Well, sometimes you might be building an application. When you're building an application, you need like you can't you can't put all your code in one file. Like it will make it cumbersome to debug or edit. Yeah. So what they do is that they they divide the code into several blocks, different files, right? So each file each file will have a new sorry each file will have a particular part of the application, right? So let's say we are building an application to count the number of students who will enter a classroom, right? Good. So we can do this. We can have part of the code a, a separate file, which that file, all that it will do is that it will define the function count over there, right? So in that case, anytime you want to use the function count, we'll just include it to our main file, right? Our main application file, so we call it. So it's like in Java, you'll see something like we have different classes, right? So each class is like a different file. So we include it within the word, the main class, the class, the test class which contains the main class, right? So that's similar to headers over here. And with headers, we can also define our own library, right? So C has inbuilt libraries. For instance, we have this standard IO, that's standard input and output. So this file contains printers, scanners, and the other built-in functions. And this standard libraries also have some functions which are defined in it so that we can use it in our code. So we can also create our own function and then include it as a header file. So there are two ways we can include the file, a header in a particular file. We have hash that include and angle bracket. And the second one is hashtag and parentheses, sorry, quotation marks, right? So this is the difference. When we say hashtag include, it means that what this header file over here that will include um, in this angle brackets. This header file is part of the compiler's path. We've added it to the path of the compiler, right? So it's in the same location as the compiler. So in that case, we put it in the word angle bracket. But this can be tedious if you want to add your own library, the library that you or your header file to the path of the compiler, right? So in that instance, I can say that um, if you don't want it to be part of the compiler anymore, you have to go and then go and remove it, right? But in the hash including quotation marks, your your header file need not to be the part of the compiler. It can be in a different word destination. But actually, um, for for safety, we include the header file we put the header file inside the projects, right? So it's a different file that we want to include. So, so if you look at this one, this standard library is a built-in header file that comes with the compiler, right? So this is in angle bracket because it's part of the compiler. So when we define our own, we put it in the word quotation mark. We say how to define, oh, sorry, hash include, and then Identification must be right our international value to include it. Okay. So let's see how we can define our own data file, right? So over here, what you do is you create a new file, right? Empty file. And I'm going to save it as a word, as a header file. Okay. So I'll make it I'll make it dot H. So I'm going to say some dot H. Right. First, okay, so with code blocks, you can actually get the data from like, right? I mostly use PS Code, and so I have to save it on like different. So data file, click it. And the full path, right? So I'm going to browse. Okay, I'm going to add it to this thing. I'm going to add it to this project, right? So I'm going to name it as, let's say, addition. Each. I'm going to say, I'm going to plug it as well. Okay, so So, code blocks have already done this directives for us, right? Um, so that's what I was talking about earlier, that if and if addition header included, or yeah, this something that the test editor did for us. So we first check the condition before we write whatever you want to write in the header file. This is so because you can get multiple files which calls a header file like, yeah, let's say we have one file and another file in which we have included this header file, addition header file. So in this case, when we add that include addition header file here again, it's like we call header file, which also call this addition header file again. So it's like we are defining it twice, and that's not allowed in C. So we say that if not defined, so if this condition is true, then we define it. So this ensures that we always define whatever inside the header file once. no matter how many times you call it. So the first thing is that I'm going to do is this. I'm going to comment on this. Okay, let me delete it, right? And I'm going to write an addition function, right? Which will take in a variable. And this time I should return it. So say int add. I'm going to take integer. Integer say x. And over here, I'm going to say return x plus. Okay, so let me do it right parameters. Another is y. Right. So return, I'm going to return the sum of them as well as x plus y. Okay. So this function is defined in this header file. So how do we use it in main.c? When we say, if we have it, like as we have it, if we say, we just say add, sorry, how do I name it? Sorry, I don't get add, and say 3, and then 4. When I run this, the compiler will tell me it's not defined. Right. Good. So it's giving us warning. So we say, okay, this is a different thing. I've commented it out, but I'm still using it. Let me comment them out as well. So I just get to pick. Good. Now this debugger, this red breakpoint is on the word add. Let's see, say undefined reference towards add. So this add is not defined yet, even though we've defined it in this file. This means that we've not included this in this file. So we're going to say hash include. And remember, this is not part of the compiler file. So we will put it in quotation and say addition. So when we do this, now we have this add function inside the header file. Or actually, it's returns, so we have to catch it. The value is returned. So let me say it returns an integer. So it int result. Let's say result is equal to this. So this result will catch it, right? Will catch the value it returns. So now I've included it here. So let me. So we have compiled it successfully. And I'm going to print the result over here. There. We print the result. So we pass in 3 and 4. We do them run. And we get 7. Yes. So with this header file, we have been able to use a function which is defined in a different file inside our main function. Right. So, okay. So this is what I was talking about earlier, because we can get a scenario where we define this several times, or even in this time, in this one, this file, we've included the addition header file once. But this is what happens. Anytime we run it, or anytime we build it, we compile it, we redefine everything again, right? So in the next, let me put it here, let me copy this line. So we've added it twice, right? In this case, when I run, it will tell me that it doesn't like multiple, something like the multiple techniques. You get confused. So yeah, so you see, this function is here. What is saying? Error, redefinition of R. So like we've called it once and we've called it again. Like we have defined this function twice in the code, right? Because we included this in the file twice. Actually, in the actual sense, you won't do this. So let me define what will be the actual case when in the real world. Let me see something like that. Let's say we have another um, header file, right? Let me create another one. This is to add in some, well, add in some. So this header file is going to add and subtract what we've written, right? With each, right? With each, with it. We debug and we so automatically put plus add, right? And just take it. So that I'll later come and explain why we have this, if not the significance of it. So in this one, we have this header file add and also what subtract. But we know that we have an addition function somewhere over here. So we can just include this header file, right? And then we have our include our system, our add function. We don't have to rewrite it. And then we just define our subtraction function, right? So we say hash include parentheses. Hey, before parentheses. Quotation addition. So we included addition, so we can use this, the addition here, the add function, right? So we say add sum, right? Void. This time I'll do void here. Add wait, add sub, right? I'll take two parameters. That is A and B. Two parameters here. So, are you recording it? Okay, so we have this add sum here, right?
I'm using a shortcut of
And over here, because we included addition, we can use the add function directly. But that add function returns a value, right? An integer value. So we have to catch it as well too. So I'll say um, sum, I'll call it sum here. It's equal to right. I'm going to pass in A and B. So I'm going to pass in this and this. So when we call this in the main function, whatever value we pass in will get passed in to this sum function, add function in this header file, right? Okay. So then we will also do the subtraction. So um, let's just say n difference. I'll call it this is equal to a minus b, right? And I'll just print it. Print um, equal to include this over here. Then I'm going to the next line to say the sum or the difference. Equal to over here. I'm going to put in this variables here. The first one is sum, right? The sum, and then this. Good. So we have these two header files. So over here, I've called this header file here because I'm using add in this main function. So I'm going to take one off and then call add sum to here. Right? Add, I'll do add sum to this one. You can see that. So that's okay. So over here we have two header files, right? But let me tell you something about it. When you run this, you will get error. Even though this is an error from the previous certificate, right? You still get undefined, you still get redefinition error. So insurers, yes. So you still have this redefinition. Even though in this we called or we included we technically included addition header file once in this main function, but we also included add and sum, which is what which has addition the addition header file included in it. So it's like okay, so over here we include addition and also we in this line we include adsum, but adsum also has addition included, right? So in the actual sense we are including this twice in this function, right? So anytime we do this, it will keep telling us that we are redefining because over here we have the add function defined in here. And we also have defined this because we added the addition data file to the added sum, right? So that is why we always do if not defined, define, right? So you say over here, you say hashtag if and define, and I'll just put in anything over here, any word. So say okay. If not defined, okay. So I'm going to put this here. Not defined, okay. Define it. Define, okay. Good. So this is like a macro, right? So this okay is a macro that holds with this add function, right? So if not defined okay, they are defined. So we will always define this whenever this macro has not been defined before, right? Good. So in this case, I'm not going to add the conditions here, and I expect it. Sorry, I expect it to run successfully. Okay. So we have them here. We have this one over here, but it's only one function that's working over here. That's the this right. So because we did not call the add sub function in the main C, so we say over here to also say um, okay. The add sub function does not return any value, so we can just put them here. Okay, we can just write them here. We can just say printf and this is what that is the passing I or 7 and then 5. So we are passing 25, 25, right? Okay, so we have our answer here is defined in this header file, and it will print this the difference in the sum here. Okay, so let's run it. Okay, okay, so I'm going to run this. It's saying what? What it is for this question. Okay, because this way, so oh, I'm printing something that does not return anything. Right, so I just have to call it. I just don't have to. I don't have to. Because the printf will take the return back. But here, it is a void function, so it has to be called just like that. Right? Yes. Yeah, so we have them here. So the first, so this first value, 7, is from what? It's from this result. And then the answer printed is 2, right? So that's header file for us. So anytime, in case you also add this to another function, it's better to do it. Um, find out whether it has been defined or not. So over here we have to. It's always advisable to uh, hidden and if not defined directive is and define a hard hardened then basic define right and probably I'm going to put in my definition here right okay so in case we have to add this to another header we have to add it to another header or a different we won't call it like multiple times right we won't define it multiple times so this will work check yeah so that's okay we are done with header files as well. So our next topic is structures, right? Okay, so this is it. We have a built-in function here. Sorry, a built-in data types like uh, int, float, double, car, and the rest, right? But how do we define our own data type? So for instance, let's say we are programming an application that will be like uh, a student register, right? Yes. So like a student register. So if you are from you have programming object-oriented programming, we have something called classes, right? So classes are just um, um, user-defined or the programmers defined data types. I'm just calling those as right. Actually, that's what class actually means, right? Okay. So in C, we don't have classes, but we have structures. So these structures are just like user-defined data types. So in the student register that I explained, right? I definitely that I cited earlier. In that application, you have something like the student name, maybe the row number, house, maybe the age, right? House to track of students. Okay, so in this case, we cannot be doing like anytime we want to define one student, we do with several lines, right? So we just do this. We just define a structure once, and then anytime we want to call a student, you want to create a student data type, you want to add a student to the register, you just um, define it as the structure that we define it, right? So I'm going to print this out so that I put in the structure and just click all. So in order to define a structure, we have to define it outside of the main function. So this is done, we say struct, and then the name of the structure say uh, student. Oh, okay, let's do it like person, right? I'm going to put in this here. So I'll say a person has what a name, right? So I'll say car, right? Character to store the name. Name. I'm going to give it 50. And the age, let's say the age. I'm going to keep it 20. So age, right? So with structures, we've been able to combine these data types, right, into our own data type, right? So we've defined our own data type of this. So if you want to create a person, an example of a person in object-oriented programming, you say an object, right? So we will say struct person termination, right? Struct person, uh, call it right? Yeah. So we have hello. Okay. So we have struct a data type called cookie, and it's of the type was struct a person, right? Struct person. So we can say we can print an argument here. We can say printf, or we can assign it here. So we can say int, sorry, cookie dot cookie dot um, age is equal to 40. Right. Now let's print it. Printf cookie dot age. Let's run it. Okay. Everything restricted. Oh, come here. So this age has been printed here, 40, right? So in this case, we have been able to create our own data type, right? Good. So if we can actually know the size of any data type, right? We sometimes don't have to memorize this if you want to check it, because you see, especially with integers are like machine specific in C, right? So on the machine, one machine it might be 4 bytes, 4 bit machines we have 4 bytes, and let's say a microprocessor, right, or an embedded system. Integer can be like uh, 2 bytes or 5 bytes, right? So that's with it. So we can check the size of any different. So let me just do this like printers. Decimal, and I'm going to say size of the size of is the size with that of the right? Right. So that's for variant. So on this machine, integer is what 4 bytes. Let me do this. Yeah, right. Right here. So on this integer is what 4 bytes here. I can also check the size of what the flute by just saying size of flute. Let's save it. So size of flute is also 4. I keep neglecting the line width. Right. This is also 4 bytes. Right. You can do that for double as well. And we say double. And double is what 8 bytes. Right. Good. So let me check the size of our structs, right? Our structure. So I'll say size of structures. Our structure for our structure data type. Let's take it for the size of it. That's going to be 56. This 56. Let's check. You can find out if it's true or not. Character, we know each character holds with 1 byte, right? Each character is 1 byte, and um, we printed integer and it was 4. So if each character is 1 byte, then we have 50 characters here. So we have to get what 50 bytes for it, and what plus 4, which should be 54. But this is giving us what 56. Something happened, and this is called what happened is called character padding in C. So the compiler will always align the members of a structure such that uh, um, they are like they fill in memory blocks, right? Yeah. So um, this is what happens. Um, 50, we have 50 characters here, right? So which will be like 50 bytes, which will go 50 bytes. But the compiler padded 2 bytes, 2 additional bytes to be 52, right? Because if you divide 50 by 8, you get a decimal, right? So let me try to use a calculator here. 62 or 50 divided by 8. And this is 25, right? So because of this now, the compiler will round off, like it will pass some additional values in order to make our memory, the location of the memory we are occupying, like the code, right? So you instead of this, so like it will do whatever possible to make sure that our members of the structure align, right? So this one will give it will give additional 2 bytes. So 52 here divided by 8. Yeah, with 6.5. Okay, so what the compiler does is that it added keywords right to it. So if you don't want that to happen, because our memory is, in case on an embedded system, the memory will have a big memory, right? So an embedded microcontroller, the memory is very small, so we always have to use the memory efficiently, right? So what you do is that you will say hashtag path. So the pragma directive I said earlier when we are dealing with preprocessors. So we say pragma, and I'm going to pack it so that I'm going to set the path into 1 so that we will always give the actual size, we won't give any file. Right. Good. So this time when I run it, I should get 54 instead of 56. Okay. So our structure now is what? 54, which makes sense because each character is what? 1 byte, and we have 50 characters, which will make it what? 50 bytes. We have an integer which is 4 bytes. So we get what? 54 bytes. Right. There's another trick here with with structures. So over here, so anytime you find a member of a type of structure, we always have to write the whole thing here, right? Struct person, if you are writing AMA, you say struct person AMA. If you are writing Mary, you say struct person Mary. Always it's like it's basic and you write it. So what we can do is that we can just put in a variable to hold this whole structure. And we'll say, let's say, I'll call this student. Right over here, before this semicolon. We can also add families because they are also first. They are also different, right? So I'll say family. So here, instead of me saying subtract person, I'll just say student. It's a student, right? I'll just say student. Right? And I'm done. The next time I want to find a farm, I'll just say farm as an item. Right? So over here, I'll just say start of what? Farm or student. see here. The thing is now outside what sound, sorry, surface which has been stored in the variable constituent, right? So let's see. What is it? Oh, and has been why this is not working. I'll be using it, but I don't know why. So let me read. Yes. Okay, so I'll figure it out later because we don't have time on our side. So that next time we are able to meet, um, I'll explain how it's done. Right. Okay, so I think this is something more about structures. Okay, so the next one, we've done, 2 hours and some minutes. I think we have to end here and then maybe later we can take sorry, linked list, right? Okay. So thank you for joining and then thank you for your time. I believe we learned something. Right. Okay, so in case that I put something which I know very well, so yeah. Please write it there and then later when we are able to meet again, then we can discuss it. Or this, in case you also don't understand something, we can break it on board the next time. All right. So thank you for coming, and then goodbye. Okay, so goodbye, everybody. Have a wonderful night.
Yes, I said.